In the NumPy section, we talked about how many Python data science packages are built off NumPy arrays. The same goes for Matplotlib. And one of the beautiful things about Matplotlib is it's about as flexible as NumPy arrays. If you can dream up a way to visualize data, chances are you can do it in Matplotlib. But there are some common kinds of visualizations than others, or some more common, ones you're more likely to come across. And these plots are the ones like line, scatter, bar, hist, and subplots, or plotting multiple visualizations on one figure. Let's have a look at some of these kinds of plots that you'll see more often, plots or figures, remember that word's kind of interchangeable, using pure NumPy arrays. So we'll start it off. So we'll go making figures with NumPy arrays. We'll make this markdown so it's a little bit communicative, and then we'll go import. If you haven't already done this, we've done this at the top, but we'll do it again. Import NumPy as NP. And we'll start off by create some data. X equals np.linspace 0, 10, 100. Might be going, hold on, Daniel, we haven't seen linspace. Well, in that case, remember, what can you do? Did you get it? Well, if you didn't, doesn't matter. We can press Shift-Tab and see what linspace actually does. So we want np, linspace, yep, start, stop, num. Okay, so they're the first three arguments. We've got 0 as start, 10 as stop, 100 as num. All right, well, let's have a look. Return evenly spaced numbers over a specified interval. Returns num evenly spaced samples calculated over the interval start, stop. So it's going to return num evenly spaced intervals between start and stop. So what do you think will happen here? Well, if in doubt, run the code. Let's check it out. Well, there's going to be 100 samples, so we don't want to see all that. Let's see the first 10. Wonderful. Well, let's see the first 100. Why not? I'm into taking risks, aren't you? So there we go. We've got 100 different samples here, 100 different floats values here between 0 and 10. So we start at 0, it goes all the way up to 10. Wonderful. We'll reduce this back to 10 to save some space. Excellent. Now, let's go plot the data. So remember, we're going to create a fig and an ax, or figure and axes. But these are the common short names for figure and axes. We'll go plot.subplots, because this is the method that we're going to be using. We'll go ax.plot, x, and let's do, because plot takes x and y, but we don't have a y, let's just do x to the power of 2. Well, let's see what happens. We'll put a little semicolon. Wonderful, we get this beautiful curved line. So the default here in Matplotlib when you call plot is a line plot. This is a line plot. So, and create a line plot. There we go. So as you can see, just a straight line. Now, use the same data. Let's create a scatter plot. Use the same data because these are the most common types. Let's write these down. We want line plot, scatter plot, bar plot, hist, and hist is short for histogram, and a subplot. They're the main types of plots we're going to be focused on. Of course there are more, but we could be going all year for the amount of plots you could do in Matplotlib. So we'll focus on the baseline ones, and then you can build upon that knowledge. So we want use same data to make a scatter plot. We'll see what a scatter plot is. So if we want to recreate it, we have to always reset fig and ax. If we're in a different cell, equals plt.subplots. Wonderful. Ax. Now we're going to use scatter. So up here we use .plot, but if we want a scatter plot, we'll see what that looks like in a second. We need to call .scatter on ax. So here we go. We want x, and then we want np. Maybe we'll do the exponential of x. And remember, if you're not sure what exp means, you can go Shift-Tab, read the docstring here, what it says it is, and if it's still not clear, you can look up the documentation. There we go. Well, it's kind of like a line, but a scatter plot is just another word for lots of dots on the plot. These are really close together, these dots, so they kind of look like a line, but they are all just dots. All right, well, how about another scatter plot? Let's make another one, just so we can see. Fig ax, I want you to get really used to typing out this. Fig ax, plt.subplots, this is going to be our bread and butter for Matplotlib. Ax.scatter, x. Let's create a wave, because we did one of those before, and that was my joke. Beautiful. So we got a nice little wave here, and if you're not sure what this is, well, this is a sine wave. And again, you can always see the docstring, or look it up. Remember the steps, you can search it up if you're still not sure after looking that. We've been using NumPy arrays, and that's what this section is, making figures with NumPy arrays. How about we create a plot directly from a dictionary? So, make a plot from dictionary, because this is just showing how versatile and flexible Matplotlib is. So if we want my almond butter store, we'll bring that back. So we want nut butter prices. That's my favorite food. Do you like it? I like it too. So we want here, almond butter, 10. It's quite expensive. Peanut butter, not as expensive where I live. So 8. And cashew butter is the most expensive. Cashews are hard to come by, you know. In short supply sometimes. So if we go here, and then if we want fig, ax, equals plt.subplots. We're getting really good at this one. And now we want, let's do a bar plot this time. So you notice the trend? We're changing this. Now I know it's kind of confusing because this is a line plot, but it says plot, doesn't say line. You're just going to have to get used to the fact that the default Matplotlib is a line plot. But now we're going to create a bar plot. So ax.bar, and we're going to pass it x and y. So our x, maybe we'll be a bit more formal. X equals nut butter prices. What do we want? We want the keys from our dictionary, because we're using a dictionary now, not NumPy array. So we want the keys here. And our y value, so we'll type in y. That's what plot or bar or scatter always take, x and y. I might put that in a little comment, x, y. Nut butter prices dot values. Beautiful. And now we might see what this looks like. Ah, error. Missing argument. Height. That's interesting. I see this. This one doesn't take y. That's a problem. Positional argument, keyword found. What if we get rid of this? My bad. This doesn't take x and y. See? You're learning something new every day. Shift tab, x. Oh, well, that is x. X equals that. That's what we can't have. We can't have that equaling that. So we're going to leave this at that. Ax.bar, shift tab. So this is a little Python thing. If you haven't seen this before, it's a syntax error where in a Python method, if you have a positional argument, say x equals this, you need something after it to go like, say, y equals this. You can't have x equals something and then followed by that. But you can have it the other way around. So see how we don't have x equals? We can have this being height equals. It'll come out with the same thing. So the first one can't have a positional argument, where the second one doesn't, but the second one can, and the first one doesn't have to. That's a little bit of a Python tidbit there. So we're getting a lot of value from this Matplotlib lecture here. Now, this doesn't really make sense. We've got a few bars here. You could kind of infer that that's prices. Let's customize it. Let's add a little bit of a title. We want Dan's Nut Butter Prices Store. And see, that little exploration that we just did before, that's going to happen, right? You're going to make mistakes. You're going to think you know things like me. And then you're going to go, oh, that's actually not like that. And then you'll look at the docstring, you'll fix it up, and you'll combine your previous knowledge and go, oh, that's why that's like that. So don't worry if it happens to you. It happens to me. Y label equals price. But what we do is we strive forward and we figure things out. Shift enter. There we go. That looks a bit better. And what can we do to remove that ugly line of text there? I believe we can do ax.show. No, well, that has no attribute called show. But we can add a semicolon up here, I believe. Or maybe down here. Yeah, okay, there we go. So we're learning on the fly here. If you want to remove that nasty line of output code, you can add a semicolon to the last line where you call ax. We've seen this semicolon before, but we've just seen where you actually have to put it. It's on the last line where you reference ax. Well, there we go. You can create your own store. We've just seen how to plot from NumPy arrays. We'll look at a little bit more in the next video, but to prevent this one from getting too long, we'll pause it here. So take a little break, create your own plot from a dictionary or a NumPy array, and I'll see you shortly.